So let's review our systems of equation word problems. Now there are three types of systems of equation word problems, at least three. The first of those that we're going to talk about is a break-even problem. And we're going to talk specifically about a particular kind of break-even problem called a cost revenue. Now break-even problems have all kinds of examples. You could have two runners and you want to know where they're going to meet each other if they started at different places on the path. But the most common one that we're going to see is a cost revenue problem, where we have a cost, how much we spent on something, and a revenue, which is how much you earn. And we want to see where we break even, which is a real life application, right? You want to know if I make an investment, at what point am I going to make that money back, and then I can begin making a profit. So let's take a look at one of those. Organically Yours wants to determine the amount of organic apples it must sell to break even. In other words, to make its cost equal to its revenue. The cost of growing and harvesting organic apples is a combination of $125 for maintaining the orchard and 25 cents per apple to harvest and clean. The company will collect revenue, so the amount of money that it's going to make, from selling the apples at $1.10 per apple. How many apples must it sell to break even? What is the revenue at this point? So again, we're looking for this break-even point. So let's first off consider what our variable is going to be. In this case, we're going to make x equal to the number of apples we need to sell, because that's what we want to know. How many apples must we sell? So x is equal to the number of apples. And now, in order to solve a system of equations, we need more than one equation. That's why it's called a system. So we need to come up with two equations. Well, in a cost revenue problem, the cost is going to be one equation, and the revenue is going to be your other equation. So let's look at our cost equation. What is going to be the cost, the equation that represents our cost? Well, the cost for growing and harvesting organic apples is a combination of $125 for maintaining the orchard. That's going to be a one-time cost, right? It's not going to be something that you're charged per apple. So it's going to be $125 for maintaining the orchard and 25 cents per apple. That means that for every apple that we sell, X, we're going to have to charge 25 cents, so 0.25x. And then on top of that, we need to pay $125 for our maintaining our orchard. So if we were to come up with an equation for that, it would look like this. Y is equal to 0.25x plus 125. That's our cost. Now our revenue is going to be the other piece of information. The company will collect revenue from selling the apples at $1.10 per apple. So how would we represent that as an expression? Well, we don't have any flat fee like we did for the maintaining the orchard. We just have the cost per apple. So $1.10 per apple, which is X. So if we were to write that out as a second equation, it would look like Y is equal to $1.10 times X. Now when you look at this, hopefully you'll see very clearly an example like when we did for substitution. We see that we have two values for Y. We have a Y here and we have a Y here. This Y is equal to this, and this Y is equal to this. So we would set those equal to each other. But more importantly, understanding in a cost revenue problem, we're trying to find the point at which they equal each other. When will my cost be the same as my revenue, the amount that I earned, so that from that point forward, I will begin making money? So let's set them equal to each other and solve, because that's what we want. We want that break-even point. 0.25x plus 125. And we want to know when that's going to be equal to the revenue at $1.10 X. At this point, hopefully this looks familiar. We want to get our variables on the same side. So I'm going to subtract 0.25x from both sides using my properties of equality, subtraction property of equality. That's going to cancel out, leaving you with 125 is equal to $1.10 minus 0.25. That's going to leave you with 0.85x. And then I want to isolate my x variable, so I'm going to divide both sides by 0.85. You can punch that in your trusty dusty calculator and give it a shot. 125 divided by 0.85. 125 divided by 0.85 is 147.9 0.058 or 0.059 if we round it off there. 0.059. Now, we are not going to sell 0.059 of an apple. So our answer is going to be X. The number of apples we have to sell is 148. We have to sell 148 apples to break even. Now, the second part of our question is how much revenue was made at this point? And revenue is how much we've earned. Well, I know that I sold 148 apples. How much did I make, or what was my value? Well, I can find that by finding Y, by multiplying the $1.10 per apple by the number of apples. So that's what I'm going to do. I'm going to plug X back into this equation. Y is equal to $1.10 times X, which is 148. And then once again, I can punch that in my trusty rusty calculator, 1.10 times 148. And I'm going to get $162.8, which is 80 cents. $162.80.